Okay, 36 is going to go pretty quickly if you watch the video on problem number 35. The concepts are exactly the same here. In this case, b is defined as the integral from 2 to x. So we're actually starting at this value right here, but the concept is still the same, guys. Capital B is an antiderivative of f. So that means that capital B is equal to, and that would be capital F. Then if we differentiate, because capital F is an antiderivative of little f. But now if we differentiate both sides, we're going to get B prime equals, and the derivative of capital F goes by a different name. Rather than capital F prime, it goes by little f. So this graph right here is equal to capital B prime of x. So if we want to find a minimum and a maximum value of b, we need to know where the derivative of b, otherwise known as f, otherwise known as this graph, a minimum happens when this graph changes sign from negative to positive, which still happens right here. So the minimum value occurs at x equals 1.5. Now, let's find what that minimum value is. So b of 1.5 is going to equal a definite integral with 2 on the bottom and 1.5 on the top of this graph right here, f of t dt. Well, the first thing we see that none of us likes is that those limits are in the wrong order. So we'll fix that, kind of, by taking the opposite of the integral from 1.5 to 2 of f of t dt. So that is now going to be the opposite of, and here we go, guys, the area of that region right there is 1/2, it's a triangle, times a base of 1/2, times a height of 1. So that's going to be a negative 1/4 now for the minimum value of b on that region. And then, let's keep going with it, we need to find a maximum value here. And a max occurs when the derivative of a function, b prime or f, this graph right here, when your derivative changes from positive to negative. That still happens right here. So the maximum once again occurs at x equals 1.5. So now, I think this will actually be easier than what we just did because the limits we want are in the right order. That should have been 4.5. There you go. So the maximum value, b of 4.5, should be, let's see, the integral now from 2 to 4.5 of f of t dt. So we're looking at a region now, starting here at 2 and ending at 4.5. So we're looking for the area of what I have there in red, which is a trapezoid, everybody, 1/2 times a height of 1, and then bases. One of these bases on top has a length of 2. The other one right there has a length of 2.5. All right, so what does that do for us? 2 plus 2.5 is 4.5. Half of that is going to be 2.25, or 2.25, and that should be our maximum value of b in this problem here.